So last class we have seen about operation states and modes of ARM Cortex M4. Okay, so the processor supports two modes of operation: thread mode and handler mode, and it will be in two states. One is the thumb state, other one is the debug state. Okay, so what is thumb state?
The state where the thumb instructions are passed.
So if the processor is executing normal program codes, basically ARM Cortex M4 supports thumb instruction. Okay, if the processor is running or executing thumb instruction, it is in thumb state. Okay, what is about debug state?
It stops executing instructions.
Yes, when the process is halted or when the process is stopped, it enters into debug mode and stop executing the instruction. Once it enters into the debug state, your instruction will not be executed. So the execution will be stopped during this debug state. Okay. And what is this thread? So let me summarize these two modes. These two modes are very important while developing your ARM Cortex M4 assembly as well as embedded C programming. Okay. So actually it gives two operational modes. One is thread mode and another one is called handler mode. So normally your application program will execute under thread mode. Okay. So this normal code access level or unprivileged access level. Okay. So what is that privileged and unprivileged? What is privileged?
It can access all the resources.
Okay. So when the program is running in privileged access level, that is program is running with privileged access level. So that case, your program is able to access all the resources in the processor. That is all your peripherals and your external devices and external memory. Okay. But in case of unprivileged access level, some memory regions are restricted or inaccessible. So few operations cannot be used and some of the registers also restricted. Okay. So the thread mode can be in privileged access level or unprivileged access level. And also we can move the processor from thread mode with privileged access level to unprivileged access level by using software techniques. Okay. So for that, we have to program control register. Is that clear, students? We can move the processor from thread mode with privileged access level to thread mode with unprivileged access level by using software techniques. For that, we need to program control register. Okay. Is that clear? So what is that? So this mode is called user mode. Normally, the processor that is always starts with this user mode. This mode is also called as thread mode. Okay, and all the exception handlers or interrupt handler will under this handler mode. Okay, so when the peripheral wants to wants to require the attention of the processor, so the peripheral may access the processor through your by raising interrupt request. Okay, so that means whenever your processor meets with any system exceptions or any interrupt which comes from peripherals, then the processor will immediately change its mode to handler mode. Okay, is that clear? So what it will do under this handler mode? What it will do? So it is changed from thread mode to handler. what your processor is going to do?
It will handle interrupts.
It will handle interrupts by executing interrupt service routine associated with that exception or interrupt. Okay. So all your ISR will be executed under this handler mode. Okay. So please remember, your processor always starts with thread mode. Whenever the core meets with system exception or any external interrupt, then your core will change its mode to handler. Okay, in order to service the ISR associated with the system exception or interrupt. Okay, but here the problem is thread mode with unprivileged access level. It cannot switch back itself to the thread mode, normal thread mode. For that, we need to raise a exception request that will be handled by the handler mode. After that, it will come back to thread mode with privileged access level. Okay, is that clear, students? Is that clear? Nice.
Yes, ma'am.
So thumb state, debug state, to access level. So user can execute the program under privileged access and unprivileged access level. And the important thing is handler mode is always privileged. Thread mode can be privileged or unprivileged. So this can be programmed by using control register. Okay. So let me demonstrate the operational mode of the processor and how actually processor switches between a different operational mode during the execution of the program. For that, we need to write embedded C. Okay. So please listen the class carefully. So from this class, I am going to teach embedded C. Okay. Compared to assembly, for placement, embedded C is very important, especially ARM Cortex M4 embedded C programming is very important. So from this class, I am going to demonstrate all your concepts using embedded C programs. And in your lab, parallelly, we will cover, after completing assembly language, we will cover embedded C program. Okay. So this is the structure of your embedded C. So you have to save your code with .c extension. So I have written simple main function here and added a while one loop and just written. See, I have written just right. So it's a very small main function which doesn't do anything useful operation. So let's understand how this actually executes on the hardware. So I have connected my Nucleo board to the PC. Okay. So please note down the structure of your embedded C. Are you able to see my screen? Yes.
Yes, ma'am.
Okay. Note it down. So I think you have knew about all the project creation and file attachment to source group. Here I have created main.c and I have been added this file under source group 1. Okay. So let me compile this. So 0 error, 0 warning. See, I have connected my Nucleo board, STM board, into my PC through USB. Okay. So for that, if you are connecting your board, you have to change your debug state from simulator to debugger. Suppose if the board supports onboard debugger, so your vendor will provide debugger software. So that should be installed in your system. Okay. So using USB port, we can communicate with that board. Okay. So I am using ST32 microcontroller. For that, I have downloaded this debugger software. Okay. So you have to select this debugger. So we can have many debugger component. So I am using ST-Link debugger. Okay. So just click on OK. So after this, we have to download this code into our hardware. For that, you have to use this one. Okay, before that, before downloading, you have to see here we have setting option. Just you click verify code download to flash. For simulation mode, there is no need of considering all those things. You can directly select the simulator and execute your code. Is that clear, students?
Yes, ma'am.
Okay. So click on OK. Okay. Click on OK. And here we have load button. So what it will do is when we press this, whatever code, it will be available in the folder that is converted into hex file. Okay. And that hex file is loaded into your ARM code. Okay. Just I am pressing this. So look at here. Look at your build output window. The programming is done. Verified OK. So your program is now loaded into your hardware. Is that clear? So click debug option. Okay. So here you can see under this internal option, we have modes and privileged access levels. Okay. And also stack. And after reset, your processor will be using this MSP, main stack pointer. Okay. So let me put a breakpoint here. Okay. I'm going to run this code. So look at here. Your processor always starts with thread mode. Okay. When I stop it, you can see that still it is in thread mode. Okay, this means the code executing in the thread mode of the processor. So the particular code, okay, this code is executing in the thread mode of the processor. And I also said that whenever the core meets with system exception or any external interrupt, the core will change its mode to handler mode. So let me demonstrate that. For that, we need to simulate a external interrupt. Okay, is that clear, students?
Yes.
So we next we will trigger some system exception. So because we have to trigger some interrupt either by using software or hardware. Okay, so we will trigger some system exception or external interrupt so that we can change the mode of the processor from thread mode to handler mode. Okay. So for that, I have chosen Watchdog timer interrupt. Okay, so that is one of the external interrupt, or sometimes it can be an internal one. So, do you heard about this word Watchdog timer?
No, ma'am.
No. So, what is timer?
Generates pulses to
Counting the external pulses or internal pulses. Actually, what I will do is now I will trigger some system exceptions or any external interrupt so that we can move our processor mode to handle. Okay, so let's generate or simulate some interrupts. Okay, for that I have taken Watchdog timer interrupt. So I am not using any hardware peripheral of the microcontroller in order to issue interrupt. Just I am simulating an interrupt which is actually hits the core of the processor. Okay, so we are going to simulate the Watchdog interrupt. Please note it down, the term Watchdog interrupt. So we have many interrupt sources. So that sources can be accepted or can be that is the particular resource can interrupt the processor at any time. Okay. So what is the purpose of this Watchdog timer interrupt is that suppose if the system is stuck at certain point. Okay. That time your system could not resume its activity, it's stuck at certain point. So that case, what this interrupt will do is it will wait for some specific amount of time. Okay, it will start counting the pulses. That is, it will wait for some seconds, and after reaching that time period, it will generate restart signal. Your system will get restarted. Is that clear? Example, your voting machine. So suppose if while voting a particular person or a particular candidate, when the system is stuck, that case, it will wait for wait for few minutes. Okay. After that, what it will do, it will generate restart signal and your system will get restarted. And also in your mobile phone, suppose if you open many windows, Google browser, that case, suppose if your processor is not able to access all the windows, suppose if the system is if your system got stuck at that point, so it will wait for some second and automatically it will generate the restart. So that interrupt is called watchdog timer. Students, are you able to follow?
Yes, ma'am.
Okay, so let's assume your voting machine and also your mobile phone. If you have mobile display, suppose we are not accessing the display for a few seconds. So automatically your display will be turned off. That is one of the example of your watchdog time. Once again. So clear till now? I want some answers. Huh?
Yes, ma'am.
Yes, ma'am.
What about other students?
Yes, ma'am.
Roll number 60. 60? Are you in the meet? Roll number 60.
Yes, ma'am.
Okay, are you able to follow this?
Yes, ma'am.
புரியுதாமா உங்களுக்கு? மற்ற ஸ்டூடெண்ட்ஸ்க்குலாம் புரிஞ்சுதா இது என்னன்னு? ஸோ நான் இப்போ என்ன பண்றேன்னா, for changing the processor mode from thread to handler, okay, I am going to simulate a watchdog timer interrupt by writing program. Okay, so can we proceed with this? Yes.
Yes, ma'am.
So this is your main program. Okay, so inside main I am going to generate interrupt. For that I need to write a function, specific function. Generate, okay, underscore interrupt. In this, we are going to, under this function, we are going to simulate watchdog timer interrupt. Okay. Is that clear, students?
Yes, ma'am.
Okay. So first, before that, include your prototype, that is hash header file. Include Stm32F446 So this is the header file. Please note it down. So are you listening along with me? Just you note down all the codes, okay? Yes or no?
Okay.
Yes, ma'am.
So we have to implement Watchdog interrupt handler. For that, I have initialized this generate underscore interrupt. Okay. So just copy this. So write a separate routine for this. Okay. Void generate void. Okay. So here we are going to generate Watchdog time. Okay. So for that, we need to use two KIMS APIs. So for simulating your Watchdog timer, KIMS core APIs are available. Okay. So first KIMS API is NVIC underscore enable IRQ. So NVIC, so it's suggesting some option. So we have many option. Okay. So here we have to use NVIC underscore enable IRQ. First, we need to enable the interrupt request. Okay. And after that, we need to activate that interrupt request by using this NVIC set pending IRQ. Is that clear, students? So it supports, what is that NVIC, non-vector interrupt controller. Your Cortex M4 has inbuilt non-vector interrupt controller. So it has the capability of handling 255 hardware interrupts exclusively for industry standard interrupts. So for that, your Keil provides a many KIMS API. So regarding this Watchdog timer, we are going to use two APIs. Okay. One is the NVIC underscore enable IRQ, and another one is the NVIC set pending IRQ. Okay. So first one is the we need to enable this particular interrupt. So enable IRQ. NVIC enable IR. Just enter, press. So this is the one of the function. Here we need to pass some values. Okay. So just you click this, and if you want to know about this particular ISR, you go to definition. Here you can see we can many options about this NVIC. We can set priority, get priority, enable interrupt request, get enable interrupt request, disable, get pending, set pending, clear pending. We have many options. Okay. So we need not to write a exclusive function for enabling. Already API is available. You have to use that API. Okay. So just you click this and go to definition. So here this is the function. Okay. So this is the function actually implemented in, suppose if you want to know the implementation. So this is the KIMS core API for NVIC enable IQ. Here they have written some function. So we need to pass this particular argument. Okay. So enable IRQ. Inside this, I need to pass a argument, that is Watchdog timer interrupt request. For that, the syntax is wwdg, okay, underscore capital wwdg underscore IRQ small n. Okay, close this IRQ. Okay, so what this function will do is it will enable your interrupt request. Watchdog timer, that is watchdog. This is the argument we are going to pass. So this will enable your watchdog interrupt. Okay, is that clear, students? Yes or no?
Yes,
Able-
ma'am.
Yes, ma'am.
So what is the next step? What is the next step? So now your interrupt is enabled. Next, we have to use another API to activate your particular interrupt. Okay. For that, I am going to use NVIC underscore set pending IRQ. Okay. So NVIC capital. So NVIC. What is the function? Set pending IRQ. I am going to use this. Okay, inside you have to pass the same argument. Watchdog timer interrupt number. IRQ is the interrupt request number. So now the function is ready. Okay, so just you click and go to the definition. Just find out it takes 0. So this is for watchdog interrupt. So it will be available in your startup file. Okay, so here we can do 96 interrupt. We can so by software techniques we can simulate these type of interrupts. Okay, for that I am using this watchdog. This is the first one. It takes 0 value. Okay, so now the function is ready. Okay, so inside the main I am going to generate this interrupt. When this function is called, the program control is transferred to this particular function to execute, that is to enable your watchdog timer interrupt and also activate your interrupt. After activating, we have to write an interrupt handler program. So that should be your interrupt service routine. Here I am going to write watchdog timer interrupt handler. Okay, so void void the function name is wwdg okay underscore irq okay handler h capital H A L D. Everything is available in your startup file and also this core cm4.h file. For that, you can refer the syntax. So wwdg underscore irq handler void. So this is going to be your ISR. So here we have to write some ISR statement inside this function. Is that clear, students? See, first I am going to generate the interrupt. Okay. So when this function call is made, your program control transfer here. So I have written that is software, that is interrupt simulation statement. Okay. So NVIC enable IRO, activate IRO. Once it is activated, your core is met with some interrupt. Okay. Appa enna pannanum? Your ISR will be called. For that, I am going to write this ISR. So up to this clear?
Yes, ma'am.
Yes, ma'am.
Okay. So we are going to do some statements. We are going to include some statements under this interrupt handler. So I'm not going to write complicated instructions. Okay, just I will implement one for loop here. So it will count from 0 to 50. Okay. For simplicity, just I am including only one statement under this interrupt handler. For make it simple, okay? Int I is equal to 0, I less than 50, I plus plus. So when the interrupt is triggered, it will count the values from 0 to 50. That's all. Is it clear, students? That's all. Your program is ready now. So So this code will simulate your Watchdog timer interrupt. Using this code, we can move your processor mode from thread to interrupt handler mode. Okay. Do you have any doubts regarding this? So this is the header file you have to use in your embedded C coding, and this is the main function. Inside the main, I have written generate interrupt. Under this generate interrupt function, I have activated your Watchdog timer interrupt. Once the interrupt is activated, we have to write ISR. So under this ISR, just I am counting the value from 0 to 50. Okay. Let's compile this. Just download this code, enter the software into debug state. Okay. So just look at here, your processors, it started with thread mode. Okay. Processor has started with thread mode. Just I will put a breakpoint here, okay, and run this code. Still it is in thread mode, okay. Just I am remove this. I put the breakpoint here and run the code. Still it is in thread mode, okay. So after execution, okay, once the interrupt is activated, okay, when the interrupt is activated, just remove the breakpoint and let me keep a breakpoint here and execute this and stop. Okay. Once. Send thread mode. Okay. Suppose if the program comes here. One second. So please hold on 2 seconds. The code is downloaded. So it is in thread mode. So actually what it will do is when keep let us keep a breakpoint here, during the execution the mode will be changed. Okay. but it should be changed. I will check it out and let you know. See, look at this code. So same code I have written here, okay? It's a different file, okay? So this is your generate interrupt function and this is your watchdog interrupt handler, okay? So after entering into debug state, so I will keep a breakpoint here, okay? It starts with thread mode. I execute this function. So still it is in thread mode, okay? Just let me remove this and keep a breakpoint here. Once the interrupt is triggered, the program control is transferred to watchdog timer handler. Here it will execute your for loop, okay? I will execute this code. Your mode is changed from thread to handler. Here it will count 50. Just look at this window. We have a watch variable window. Here it will count value 50. So after reaching 50, again the program control came back to main program. It changed into thread mode. Is that clear, students? Is that clear? Now it is in thread mode. See, first initially I kept a breakpoint in the main generate function. So listen carefully. I will demonstrate once again. So run the code. It is in one second. Remove the breakpoint and keep the breakpoint, the generate function. Okay, and run this. It is still in thread mode. Okay, remove this and keep a breakpoint here and run this code. Still it is in thread. Okay, remove this. Okay, keep it there because using software only we are triggering interrupt. Okay, we are not using any hardware peripherals. Using breakpoint we can demonstrate your mode change. Okay, so I kept a breakpoint here and execute this. Okay, one second. So remove this and keep the breakpoint in this point. Okay. Present thread. I will remove this, keep it here and execute this. Okay. It is in handler. Okay. Let's remove this and keep this here. It switches back to thread. Okay. In this way, we can move the processor mode from thread to handler and handler to thread. Is that clear, students? Yes.
Yes.
Yes, ma'am.
This I will post this code in the chat box. You can try it out. If you have any free time, you can try it out. Please note it down. This is it's very important application. Using software, we can generate a particular hardware interact using Keil GIMS APIs. By using Keil GIMS APIs. Do you have any doubts? Next class we will see
No.
about